Hello everyone, we are Team 14 and today we will present our analysis and redesign of a blender. Our team members are Aditya Maheshbang, Aryan Vardhan Pilli, Aditya Gidupuru, Sahil Avinash Ahambir, Anirudh Krishnamurthy and Sunaya Talmaki Subramanya. About the product, a blender is a versatile kitchen tool used for blending, puring and emulsifying. We focused on portable models that offer convenience on the go. Key advantages include time saving, nutrient retention and easy cleaning. Product description. We choose a blender designed for two customer groups. The primary customers are athletes needing quick shakes, while the secondary customers are home users wanting portable options for smoothies and soups. We anticipate annual production will exceed 100,000 units with scalability to meet the demand. This slide breaks down the blender parts such as casing, blade, motor, and handle. Each component is essential for functionality. The exploded CAD model helps us visualize the assembly. The fast diagram maps how the blender's main functions like process food, ensure safety are connected. It helps identify key areas for design improvement and spots potential redundancies or inefficiencies. This guides our focus on enhancing both functionality and manufacturability.
Slide breaks down the assembly of a hand blender, detailing its main components. Starting with the casing assembly, upper, lower, and middle sections, it forms the outer shell. The motor blade mechanism includes the motor, blade shaft, blade, and coupling, crucial for blending. The base and exterior components like the brand cap, blender stand, and metal base provide stability. Lastly, internal structure and control components such as the chassis, rubber support circuit, and buttons enhance the functionality and user control. Of assembly sequence prioritizes the internal structure and mechanism first, followed by the casing, control components, and ending with the base. This order simplifies assembly, allowing checks at each stage and quality control and improving maintenance and serviceability. The table compares two assembly sequences on ease of handling, fastening, and parallel assembly. Sequence 2 excels in handling and fastening, although it ranks lower for parallel assembly. Overall, Sequence 2 offers more efficient, higher quality production approach.
Here we have function component mapping matrix, where we can visualize how different components of the blender contributes to the specific functions. As you can see here, most of the components perform the multiple functions. For instance, a blade is used to perform the function of mixing liquid as well as breaking down of the components. The function increase mode and the decrease mode are performed by the 6 different components of the blender. In a conclusion, this function component mapping matrix optimizes the relationship between a product's components and their corresponding functions, enhancing the design efficiency and the functionality.
So let's talk about bill of material and cost estimation. The table provides a detailed breakdown of bill of material for the product, highlighting each part's material, manufacturing processes, and the associated costs. The majority of parts, particularly the casing and other plastic components, are produced using injection molding, which is a cost-effective and efficient process for the high volume production. However, due to the high number of casing components, such as the lower, upper, and the middle casings, this significantly impacts the total cost, as these parts collectively require more material and assembly time. Notably, the motor and the circuit component will be outsourced and are therefore not considered in the manufacturing processes, although their costs are still reflected in the overall cost per unit and assembly time. Despite outsourcing these critical components, their higher unit costs, especially for the motor, remain the key contributor to the total product cost. Overall, the total assembly time is around 65.5 minutes with a total cost of around $90.3, showing a balance between in-house manufacturing for the majority of components and external sourcing for the specialized parts.
The above slide shows the quad chart for DFA where specifically the high cost, high function quadrant, critical parts like the motor, blade assembly and the gear significantly impact both performance and cost. To optimize, we can focus on redesigning these components to use more cost effective materials and streamline assemblies. Part integration such as combining the motor and blade into a single unit reduces complexity. Presents the component commonality table with customer needs on the left and blender's performance and modules on the right. The left side highlights shared needs like mixing liquids and reducing noise, along with unique requirements for each customer group such as temperature monitoring and vibration reduction. On the right, we see the blender's foundational platform like lower casing and specialized modules, including motors and blender stand. This modular design allows for easy customization to meet different needs of the customer effectively and efficiently. This slide illustrates a product family design for the blender with two variants targeting different customer segments. On the left is variant 1, designed for primary customers featuring a compact structure. On the right, we have developed a new variant specifically tailored to meet the needs of a secondary customer group. The difference between the variant 1 and variant 2 CAD models lies in the modification of the blade fixation mechanism as highlighted in the slide. By incorporating this new blade fixation style, the blender can effectively handle various food preparation activities such as grinding vegetables, blending ingredients, and more. The slide shows two versions of the assembly sequence for the product family. The top sequence represents the standard assembly process starting from the motor to the brand cap with each component added in a specific order. The modified sequence on the bottom rearranges some steps, particularly the metal base and lower rubber ring, to streamline the process and potentially improve assembly efficiency. This modification can lead to faster production times or easier assembly for operators.